In this video, we are going to go over how to create a hexahedral mesh for this geometry. So by the end of the video, this is the mesh you can expect, and this is going to be the starting geometry that we have. Now, this video is inspired by a post on Reddit. This individual wanted to take this geometry and wanted to make it mappable. So in this video, I'll discuss how to make this geometry mappable so you can go ahead and create your hexahedral mesh. So to get started, let's go ahead and delete our old geometry and the old mesh, and let's go ahead and re-import the geometry. Now, the geometry could have come from CAD, SolidWorks, or some other CAD program. When we go and try and create a hex mesh on this, you'll notice that the entire geometry turns red. That means that the mesher cannot mesh this in an easy way. Here, if you click on this option cells and you hover over the geometry, the mesher sees this geometry as a single cell. Now that's a problem for us. Since we don't have a simple cell, it cannot create the hex mesh. So let's go ahead and create separate cells from this one solid. We'll go ahead and jump to geometry edit tools. We'll go to split tool. Here we'll select this split method, split using surface. And then we'll go ahead and hover over the geometry. We'll select it. It turns orange. Click the scroll wheel or the middle mouse button or the MMB button. It turns magenta. Now we need a surface to split this geometry. So we'll select this face. It turns orange. Click the scroll wheel. Click the middle mouse button. Click MMB. And then it performs the split. The split is indicated by these white dashed lines. So if we scroll out and then move a little bit more, we see these dashed lines. Now let's go back to the mesher and let's go ahead and look at what our cells look like. So remember, we're using this option in this vertical toolbar. We're using this cells option. If you hover over the geometry, we now get individual cells. Before, the entire solid geometry was seen as a single cell, but we split the single geometry and now we have single cells. Now, what we can do with the mesher is the following. We can mesh the individual cells. So let's go ahead and do that right now. Let me look at these options. Okay, so let's pick one of these cells and let's mesh it. So the way the hex mesher is working, let me see if I can demonstrate this. The way the hex mesher works here, it selects a starting face on the cell. It picks maybe this face. It creates a mesh on this face, and then it walks or it extrudes that mesh. It walks that face. It walks these elements. It extrudes these elements onto the other side. So now this cell is so-called mappable. It's mapping one face to the other face to create those hexahedral elements. Now before, the problem was the geometry was one geometry with one cell. There really wasn't a single face you could use to create a hexahedral mesh for all the exotic geometries that we had here. So what we did, we separated the geometry into separate cells. So here, let me show you another example. Here, the shaft, if you will, this is one cell. So what the mesher is going to do, it's going to create a mesh on one face, and then it's going to extrude that face. It's going to extrude that mesh onto the opposing face. So this shaft, this single cell, is now mappable. So now you can go ahead and select the individual cells one by one, or you can select all the cells and then perform the hexahedral mesh operation. So here is what one version of the mesh can look like. Okay, now we need to move this back to hypermesh. How do we do that? You right click on the part, you click export. Let's go ahead and save this as part 1. And let's go ahead and open part 1. First, let me go ahead and click export on this other window. And now let's open that file. So this is a bulk data file. All the elements, all the nodes for that mesh are now in this file. You can take this mesh, you can take this file, you can import it to HyperMesh. You can import it to SimCenter, you can import it to FEMAP, you can import it to other programs. This mesh file is kind of I know some people are going to have an opinion on this. This mesh file is kind of a universal mesh file in the FEA world. So the good news is that you can split your geometry here. You can get the cells. You can now get mappable geometry. You can mesh the geometry and you can output this universal mesh file, and then you can import it to whatever other preprocessor you're using. Okay, now we're almost at the end of the video. Just in case you want to know what program this is, let me go ahead and show you which program this is. This is MSC Apex. If you're a student, you can actually get a free version of this program, so you can go ahead and practice what you saw in today's video. I believe if you Google MSC Apex Student Edition, you'll get more information on how to get a download, a free download of this if you're a student again. Okay, now let me go ahead and talk about a few other things. Okay, now when you look at this mesh in more detail, now at this point you can either stop, or if you want to look at what else I have to say, you can continue looking. If you look at the mesh, some of the elements are kind of distorted. Here I'll walk you and explain why some of this distortion happened. Okay, so let me hide the mesh for a quick moment. If you look here, there is an edge here. Let me go ahead and highlight the edge. So this edge, when you execute the mesher, this mesher sees this geometric edge here. So the mesher will try to create elements that follow the edge. Here, what's actually happening, the mesher is actually seeing a point. So let me show you what that point looks like. If you look here, there is a point. Okay, let me go into the mesher sometimes. Or here, let me see what's the best way of showing you that vertex. So here's that point. That point here is being seen by the mesher. So the mesher, when it tries to create a mesh on the face, it will honor that point. It will make sure that the element corner lands on that point. Sometimes this is okay, sometimes it's not okay. In this case, maybe it's not okay because one of the elements ends up being very distorted. So how do you address that? Let me go ahead and delete the mesh, and let me remesh this one single cell. So let's go ahead and mesh this single cell. Again, it's created a corner of the element that honors that geometric point. Now, let's go ahead and suppress this edge. And you notice as soon as we suppress this edge, which ends up suppressing this point, the mesher no longer has to honor that point. So that element is not as distorted as it was before. And now let me go ahead and see if there is another. So here is another example. The mesher is trying to honor this one point. You can click on the edge, and then if the point is still here, you can suppress the point. And then let's go ahead and rotate the model. And we'll go ahead. Here's another example where the element corner, it's following the geometric point. So we'll suppress this edge. And then the mesher no longer has to honor that point and edge, if you will. And then we'll do that again here. Now, we still have some elements that are distorted. Now, what's going on is the mesher is trying to squeeze in elements in this very small piece of geometry, in this very small face. One other option that you have, you can make the element size you can make the element size a little smaller. This will help. So let's go ahead and make the element size a little smaller. So you can see some of the elements are less distorted than before. And then you can use different approaches to help make the elements more to your liking, if you will. Okay, now some of you might be asking, okay, do I have to suppress these edges one by one? The answer is no. You can just select all the edges and then you'll let the algorithm decide what to suppress for you. Now, one problem with this is the following. Let's go ahead and turn on the suppression tool. So here, let me suppress this one edge and let me suppress these points. And you know the points and the edges are suppressed when they turn purple. Now, here I can select all these points and these vertices, and then the algorithm should suppress it, but it doesn't suppress it for the following reason. This face here, this face is curved, and then this face is flat, and then this next face is curved again. So this changing of curved to flat to curved again, the algorithm is deciding, you know what, maybe it's better that I leave the edge there. You can disable that with this checkbox. Keep vertices at curvature change. So again, you're going from a rounded face to a flat face and then rounded again. Here you can disable that. You can say, you know what, it doesn't matter if the curvature is changing. Just suppress the edges and the points. So here, you notice if we rotate the model, we now have selected these edges and we've suppressed them. Let's go ahead and select all the other edges in the model. And then you'll notice that all those edges have been suppressed for us automatically. Now let's go back to the mesher and let's go ahead and remesh this. Here, let me go ahead and increase the element size a little. And then here you'll notice I've only selected one cell. Interesting to note here is that now one of my cells is no longer meshable and it turns yellow. I suspect that's because I have two cells that have already been meshed, and that makes it difficult for the mesher to create a mesh. So what you can do is you can delete the entire mesh and then you can start again. So you can either select all the cells like this. You can drag a select box and mesh all the individual cells, or you can use this other option. So right now we use the cells option, and then when you hover over the geometry, or here, let me select solids. When you use solids, it'll use that one single solid. So you notice that when I hover over it, it selects the entire solid part and all of its cells, and then it'll go ahead and create the mesh. Or alternatively, you can go ahead and use a single cell option. So that would be this button here. And you can hover over the individual cells. So you can use the solid option or the cells option. If you use the cells option, you have to hover over all the cells, and then you have the mesher do its thing. Okay, then again, you can export the mesh. Again, this mesh file is kind of universal. So you can move this mesh into another program and continue your work. And here, let me show you and prove to you there are elements and there are nodes here. So again, this is kind of a universal file, a universal mesh file. You can move this to HyperMesh or some other tool. And again, if you want to follow again with today's tutorial, today we're using MSA Apex. You can download a free version of Apex if you're a student. So there's that. Okay, so we're pretty much at the end of the video. Again, we wanted to go over the following. We had this geometry we wanted to make it mappable so we can create a hexahedral mesh. So why do we need to make it mappable? So the way the hexahedral mesh works is the following way. It takes one face, it creates a series of elements, if you will, and then it extrudes that mesh onto the opposing face. It maps that face to the other face, and now we have a hexahedral mesh. The problem that we had before is that this one single cell, this one geometry was one cell. So it couldn't use that approach where you create a mesh and you map it to the other side. It did not know how to do that. So what we had to do is the following. We have to split this one geometry into individual cells. And then the individual cells are mapped mesh, if you will. And then doing it this way then gives us the final mesh that we wanted, a hexahedral mesh. Okay, so that's it for today's video. I hope you enjoyed it, and as always, thank you for watching.